All right, line P1, learning task number 11. We're going to describe the construction and features of autotransformers. So we've looked at what we have referred to up until this point as isolation transformers. And an isolation transformer is simply just going to be a transformer where we're going to have one side, the primary, we're going to have another side, the secondary, and then in between those, we have got no electrical connection. Everything that gets transferred from one side to the other all happens through the interaction of magnetic fluxes inside of the core. Autotransformers are now going to go and take one of these sections over here and they're going to go and link it up. They're still going to use the core, but they're going to take that section that we had over there. They're now going to go and attach it on over here, and this way the flux from either one of these is going to be able to cut through to the other one. And altogether, we're going to get more efficient types of transformers. They are not perfect. They do have some dangers. They have got some, shortcomings as well, particularly in the way that they no longer serve to, filter as many of our transients and other components that we might have that give us poor power quality. But they are very, very useful for a number of these bullet points that they list out below. First of all, when I've got to do with just a tiny little increase or decrease in my value of voltage. Nothing huge. There's some dangers when we start to go huge, but tiny little ups and downs are going to be perfectly fine. We're also going to use them for reduced voltage starting, basically for a way to manage the current for squirrel cage induction motors. That's a three-phase topic that you will cover very in-depth in third year. But for now, we just can say that an autotransformer, properly configured, will help us reduce inrush onto a motor. We'll use them inside of power supplies where we need to have multiple voltages, particularly things like test benches, not just in the lab, but inside of a lot of industries. We'll have test benches where we're doing research and development and we need to have multiple voltages available. And last of all, we'll use them in automatic voltage regulators to compensate for line drop as the load changes occur. These are usually going to be large industrial systems, usually governed by BC Hydro, although in some large enough industries, big mines and things like that, they will have their own. But it's just going to be a way that you can be monitoring your voltage of your system and then kicking it up or kicking it down as need be. An autotransformer is still a transformer, which means that the rules for transformers still apply, particularly that one that we love the most, VA in, is equal to my VA back out on a autotransformer. Same as a regular transformer. We can also go and use autotransformers to either step up values of voltage or to step them down. Let's take a look at a short little example on each one. This one over here is going to be a step-down autotransformer, where I'm going to go and feed out a lower value of voltage on my secondary, 208 volts that they give us in their description, with a higher value of voltage on the primary, 240 volts that we're going to go and carry in on that primary. What we have is we have got sections of winding that are going to go and have current traveling through them that is simultaneously going to be delivering out to the load as well as coming back into the source. And we'll cover where all of the Kirchhoff's law of currents are going to go and come from. But what we will see is that current will go in from one of my primary, let's say it goes in here. Some of that current might go out to the actual load itself. We'll draw this thing as a resistance for now. Some of it's going to go out here, but some of it is going to go up and through here. And as it goes up and through here, we're going to go and have flux interaction inside of my winding. We're going to have volts per turn that are going to be induced across it. This current that's going through the load is also going to join back up. Both of those currents are going to join together over here and then give us a total amount of current that's going to be the same coming back out as what we had heading into this. We will do those magnitudes and how those interact later on. The important thing for us to note is that there is current inside of both windings, and therefore there's going to go and be flux linkage inside of both of these windings over here. Yeah, it's a smaller, lighter transformer. They talk a little bit underneath that one about the fact that they're going to require less copper. A lot of our transformers are also wound with aluminum, but they are going to be lighter and smaller. They will be less expensive because the materials used are going to be less, as well as I'm going to be sharing some of my connections. I don't need to have as much, level of insulation going across with these ones. We do also have fewer losses because there's fewer electrical components, wires and things like that. Therefore, we also are going to end up with fewer losses that are going to be resulting from that one. Some of our energy is going to go and transform through the coil into the core from the core back down into a coil. We'll cover that one later on. Some of it is going to be conducted directly through here to my load, coming back through, and then it's conducting all the way back out. Step-up autotransformers work just as well. Step-up over here, they are using this thing to go and bring this thing from 208 back up to 240. And to give the example of a machine that has got electrical heaters in it that's rated for 240 volts, but we are not putting out the full value of voltage. We're putting it onto a 208 volt system, so we need to go and increase that one. If you want to go through it, you can just give yourself, a wattage and just use the E squared over top of R, and you'd be able to go and establish those same values where they talk about, this 75% power that we would have out of this one. That's not important to what we're trying to go and show over here. Once again, what we're trying to show is that we are going to go and have a primary, which is going to go and have my electrical load over there like that. We're going to have current that's going to go through there. As that current goes through, it is going to go and flux our main winding, which is going to go and cut back into these windings over here, where it's going to go and generate that additional amount of volts that we're looking for, that extra 32 volts that we need to go and bring this thing all the way up to 240 volts. And so we're going to have, once again, some current that is going to hit this node, travel straight through, go through my load, come back into the transformer, through, and back down and in. Once again, the actual math, the current values and voltage values are going to be covered. We'll just cover those ones a little bit later on. Right now, we're just showing how these things are laid out. Multitap transformers are going to be used anytime that we need multiple different values of utilization voltage over here. This one, where we have got a primary that is a higher value of voltage over here, we can then go and drop down to this value of voltage, this value of voltage, this, or we go all the way across line to line. Because it is a transformer, that also means that we could have just fed in off of this one, and then we would be able to get this large value voltage out, plus this next value, etc. Not used in general power distribution inside of a plant or anything like that, but very commonly used inside of testing bays where we have, multiple components that need to get taken in. Some really large industrial places have got repair shops on them, and those repair shops are going to have maintenance electricians who never leave the shop. It's nice and warm and dry. They put on the coveralls when they get there in the morning. They turn on the shop heater, and they just repair stuff, but they need to have a bunch of different voltages available, and usually that's going to be through a system like this. A more common type of autotransformer that's multitap is going to go and be this one over here, where we are going to go and take our line and neutral, and we do need to identify them over here. This one is the neutral, this one here is the line, and where I'm going to go and connect an autotransformer that's going to go and have a second winding with the same size as this first one over here, so that when we drop across here for 120 volts, we will go and magnetically couple that to this one here, so we can generate an additional 120 volts. Bring us out to that 240 volts. So we come to that 120, 240, or we brought this thing back down to a Edison type of primary. They can be really tricky, these ones, to go and calculate the currents and the voltages, where they're coming from and where they're going, because we got 3-wire Edison circuits on this side over here. Resistances going across to my main lines, that main resistance across there, etc. That's all, confusing in and of itself a little bit at times with the Edisons. But then what we have to do is we have to take that back out of here, and we have to figure out where all of these currents are going to go. When we deal with these ones, we are going to deal with these ones very much on the VA in is equal to my VA out. Find your watts, add all your watts together, take that to this side, figure out, what your VA in there and the voltage, divide the volts out, figure out your amps, and from there work back in towards the center. We'll see those ones later on. The big consideration with these ones is that neutral needs to be on here. Now they're showing a ground on here. We haven't done grounding and bonding yet this year. We will get to grounding and bonding, but we need to have every single neutral out there needs to be grounded as well. This, if it is a true neutral, means that it will be connected all the way back to the main neutral, which that main neutral is going to go and be grounded. We should not be applying a second ground at this one. It is here just merely to indicate that the neutral is already grounded. All right, variable autotransformers. Variable autotransformers come in a multitude of different shapes. The most common one is going to be what we refer to as the toroid. Toroidal is just a fancy way of saying donut shaped. It just sounds more sciencey, when we say that is a toroidal looking, hotcake, rather than that's a donut. over there. So you can throw that out in your day-to-day life there. Start referring to stuff as toroids. Toroids are just going to be wrapped windings that go all the way around here. What we'll usually see on these ones is they're going to epoxy coat them, and then they're going to go and lightly skim off. They're just going to sand all of the varnish off of these ones over here, the epoxy, so that then they can access it. You'll see these are going to be bright, shiny copper all the way across here. And then what we'll have is we will have a wiper arm. That's this thing over here that is going to go and slide over top and allow us to adjust where the windings themselves are. They show that over here where we have got a primary. We're going to go and feed that primary voltage in. Whatever we feed in for the primary is going to go and have a certain number of turns. We're going to have volts per turn. We can go and add onto these other ones over here. And then our secondary, we can adjust that secondary here. You know, it would be a low value of voltage between this point, which is fixed, and this point over here. If I move this thing up, we would get to be able to take it all the way to higher values of voltage than what our source itself actually has. All right, that is the basic layout of these things. We're going to go into learning task number 12, which is actually a fantastic learning task. I absolutely love it because it's like pure magic. We're going to go and see stuff that is going to be like these huge increases in volts and currents and stuff like that on them. Yeah, we're going to have to break it apart into a couple different videos though, because there is a bunch of different things on here. And so it's easier to kind of go through those one at a time.